Recent Pentagon assessments indicate America's Minuteman III intercontinental ballistic missiles can reach global targets within 30 minutes of launch authorization. Recent upgrades to Minuteman III guidance systems, the Trident IID5LE program, and B6112 life extension modifications for strategic bombers have enhanced America's nuclear strike capabilities. Modern research on nuclear winter effects and updated casualty models using current population distributions reveal that today's weapon yields produce consequences far exceeding Cold War projections. The Minuteman III circular error probable has improved to approximately 30 feet with W87 alternative fusing systems, delivering warheads with roughly 40 times the destructive power of weapons used in 1945. America's approach to nuclear warfare in 2025 reflects these technological advances and current threat assessments that reshape our understanding of nuclear conflict. America's nuclear arsenal in 2025. Current global tensions have pushed America's nuclear capabilities to their highest readiness level since the Cold War. But what exactly does the United States have at its disposal right now? Strategic Command operates a nuclear arsenal that has undergone comprehensive modernization programs between 2020 and 2025, transforming America's nuclear warfare capacity in ways that fundamentally alter the strategic landscape. This modernization process has prioritized technological advancement over raw numbers, creating a nuclear force that achieves greater destructive potential with fewer total weapons than previous generations of American nuclear arsenals. The 2025 nuclear inventory represents a fundamental shift from quantity to precision, with fewer total warheads but dramatically enhanced accuracy and destructive potential. Strategic Command now operates under New START treaty limits with targeting precision that has improved dramatically since 2020. This reduction in total warhead numbers reflects advanced targeting algorithms that calculate optimal weapon placement for maximum strategic effect. The precision improvements stem from upgraded inertial navigation systems and enhanced GPS integration that allow warheads to navigate with unprecedented accuracy when satellite communications remain operational. New guidance systems installed between 2022 and 2024 allow single warheads to achieve what previously required multiple strikes. These guidance upgrades incorporate modern navigation replacement programs that process real-time atmospheric data, adjusting flight paths to compensate for wind patterns, temperature variations, and other environmental factors that historically reduced accuracy. The Minuteman III modernization has achieved circular error probable measurements under 100 meters compared to historical accuracy of approximately 300 meters. Advanced terminal guidance systems activate during the final approach phase, using ground-penetrating radar to identify exact target coordinates and adjust impact points within meters of intended destinations. The modernized arsenal includes upgraded warheads with variable yield capabilities, allowing commanders to adjust explosive power based on specific targets. The B6112 gravity bombs feature dialer yield technology that provides yields ranging from 0.3 kilotons for tactical strikes against military installations to 50 kilotons for strategic attacks against hardened command bunkers. The W87 submarine-launched warhead delivers approximately 8 kilotons, while the W87 alternative provides roughly 335 kilotons for the most demanding targets. This flexibility allows military planners to optimize explosive yield for each target category, maximizing military effectiveness while controlling collateral damage in surrounding areas. Advanced fusing systems now enable ground-penetrating strikes against hardened bunkers that were previously considered immune to nuclear attack. The new fusing technology incorporates multiple detonation modes, including air burst, surface burst, and delayed ground penetration options that can be selected during flight based on target characteristics transmitted through satellite links. Ground-penetrating warheads utilize reinforced nose cones manufactured from depleted uranium alloys that maintain structural integrity while penetrating up to 100 feet of reinforced concrete and steel. The delayed fusing systems allow warheads to penetrate deep underground before detonation, concentrating explosive force within confined spaces to maximize damage against buried command centers and weapons storage facilities. Integration with satellite networks provides real-time target updates during flight, meaning missiles can be redirected to secondary targets if primary objectives are destroyed. The satellite integration system utilizes a constellation of military communication satellites that maintain continuous contact with nuclear weapons during their flight trajectories. This communication capability enables mid-course corrections based on updated intelligence about target status, enemy movements, or changing tactical requirements. Submarine-launched ballistic missiles carry multiple independently targetable re-entry vehicles that can engage separate targets, while land-based Minuteman III missiles carry single warheads optimized for their specific assigned objectives. Command authority has been streamlined through new authentication protocols, reducing launch authorization time to under 5 minutes for Minuteman missiles. The streamlined authentication process incorporates biometric verification systems that instantly confirm presidential identity through multiple biological markers, including retinal patterns, voice recognition, and DNA analysis from saliva samples. Quantum encryption protects all command communications from interception or manipulation by hostile forces, ensuring that launch orders reach nuclear forces without possibility of enemy interference. The new protocols eliminate redundant verification steps while maintaining security standards, allowing rapid response to time-critical threats without compromising command authority integrity. These improvements mean America's 2025 nuclear force can accomplish strategic objectives with 40% fewer warheads than previous war plans required. The efficiency gains result from enhanced accuracy that reduces the number of warheads needed per target, variable yield capabilities that optimize explosive power for specific objectives, and improved targeting algorithms that eliminate redundant strikes. Strategic planners have recalculated weapon requirements for all target categories, determining that precision improvements allow successful mission completion with significantly reduced warhead expenditure. This efficiency creates additional strategic reserves for extended conflicts or unexpected target requirements that emerge during active operations. The mathematical transformation of nuclear warfare reflects advances in computational modeling that calculate optimal weapon allocation across thousands of potential targets. Computer simulations process vast databases of target characteristics, weapon specifications, and environmental factors to determine the minimum number of warheads required for successful strategic objectives. These calculations incorporate probability assessments for weapon reliability, target hardness, and defensive countermeasures to ensure high confidence in mission success rates. The modeling capabilities enable strategic planners to achieve greater destructive effects against enemy capabilities while reducing the total nuclear commitment required for successful outcomes. The result is a leaner but exponentially more lethal nuclear capability that redefines the mathematics of nuclear warfare. America's 2025 nuclear arsenal achieves strategic objectives that previously required massive nuclear exchanges through precise application of advanced weapons technology. The combination of improved accuracy, variable yields, real-time targeting updates, and streamlined command procedures creates a nuclear force capable of rapid, decisive action against any potential adversary. These individual components work together as part of a larger integrated system that coordinates all nuclear delivery platforms into a unified strategic weapon. The modernized nuclear Triad. The traditional three-component structure of land-based missiles, submarine-launched weapons, and strategic bombers continues to form the backbone of American nuclear strategy. But each component now incorporates technological advances that fundamentally transform their operational capacity. Modern nuclear weapon systems feature improved communications, missile upgrades, and new strategic assets that create a coordinated strike capability, operating with precision and speed previously impossible to achieve. Each leg of the Triad now features cross-communication systems that allow real-time coordination between land, sea, and air-based weapons during active operations. These communication networks utilize multiple frequency bands, including extremely low-frequency radio waves that penetrate ocean depth to reach submerged submarines, satellite-based encrypted channels that connect airborne bombers, and hardened fiber optic cables linking ICBM control centers. The cross-communication capability enables dynamic mission planning, where weapons from different platforms can coordinate their approach timing and adjust target assignments based on battle damage assessments. The ground-based strategic deterrent program has begun replacing Minuteman III missiles with next-generation ICBMs. The new LGM-35A Sentinel missiles represent a complete technological overhaul of America's land-based nuclear deterrent, incorporating advanced propulsion systems and guidance capabilities that surpass anything previously deployed. Northrop Grumman received a $13.3 billion development contract for the Sentinel program, which carries a total acquisition cost estimated at $141 billion. The program includes comprehensive modernization of launch silos, command and control infrastructure, and support facilities across missile fields in Montana, North Dakota, Wyoming, Colorado, and Nebraska. Columbia-class submarines now entering service carry Trident IID5 missiles with life extension modifications that extend their operational range to 8,500 miles. The USS District of Columbia began construction in 2020 and is expected to achieve initial operational capability in 2031, marking the beginning of the Ohio-class replacement program. Each Columbia-class submarine carries 16 Trident IID5LE missiles in vertical launch tubes, representing a reduction from the 24 missiles carried by Ohio-class boats, but compensated by improved missile performance and warhead capabilities. General Dynamics Electric Boat serves as prime contractor for the Columbia program, with Huntington Ingalls Industries Newport News Shipbuilding providing major subcontractor support for the $132 billion program. The B-21 Raider stealth bomber, operational since late 2023, can penetrate advanced air defense systems that would destroy older aircraft. The B-21 incorporates next-generation stealth technology, including advanced radar-absorbing materials, carefully sculpted airframe geometry, and electronic countermeasures that reduce radar signatures to levels undetectable by current air defense radars. The bomber features digital architecture that enables rapid software updates and mission system modifications to counter emerging threats. Production costs average $550 million per aircraft, with the Air Force planning to acquire sufficient numbers to maintain continuous nuclear alert capabilities while supporting conventional bombing missions worldwide. New long-range, standoff missiles carried by these bombers can strike targets 2,000 miles away while the aircraft remains in safe airspace. The AGM-181 LRSO missile program, developed by Raytheon under a $2 billion contract, will replace the aging AGM-86 air-launched cruise missile by 2030. These missiles carry refurbished W84 nuclear warheads and incorporate stealth technology that allows them to penetrate sophisticated air defense networks. The 2,000-mile range enables bombers to launch strikes while remaining hundreds of miles away from enemy territory, reducing aircraft exposure to surface-to-air missiles and fighter interceptors. The Space Force's evolved Strategic Satellite Communications Program will deploy new satellites across multiple orbital planes to replace the current, advanced extremely high-frequency system. Boeing received a $2.8 billion contract for the S program, which will provide highly protected communications capabilities for nuclear command and control operations. The constellation will include satellites stationed across multiple orbits, utilizing protected waveforms and classified capabilities to provide secure communications to nuclear forces worldwide. Command integration extends beyond communication systems to include coordinated mission planning that treats the three legs of the Triad as components of a single weapons system rather than independent platforms. Strategic planners can now develop attack scenarios that sequence weapons launches from different platforms to achieve specific tactical objectives, such as using ICBM strikes to suppress enemy air defenses before bomber penetration, or coordinating submarine-launched missiles with land-based weapons to overwhelm target areas simultaneously. This integration capability transforms nuclear warfare from a collection of separate platform missions into unified strategic operations that maximize destructive effectiveness. This interconnected triad creates redundancy so advanced that destroying any single component triggers coordinated responses from the remaining systems. The system's redundancy means that even catastrophic losses to two legs of the triad would still leave sufficient nuclear capability to destroy any potential adversary as a functioning society. The modernized triad represents a fundamental shift from Cold War nuclear doctrine, emphasizing precision, coordination, and technological superiority over raw numbers of deployed weapons. Each component has been designed to operate independently while contributing to an integrated strategic response that can adapt to changing battlefield conditions and enemy countermeasures. Land-based ICBMs, the immediate response. America's land-based missiles provide the fastest nuclear response capability, with the 400 Minuteman III intercontinental ballistic missiles maintaining continuous alert status since 1959. These weapons can transition from peacetime readiness to launch configuration faster than any other nuclear delivery system, making them the primary choice for immediate retaliation against incoming threats. The land-based missile force operates from hardened underground silos distributed across Montana, North Dakota, Wyoming, Colorado, and Nebraska, positioning them beyond the reach of conventional military forces while ensuring geographic dispersal that prevents single attacks from eliminating the entire force. The remaining 400 Minuteman III missiles have received comprehensive upgrades, including new Mark 21A re-entry vehicles with enhanced penetration aids. These re-entry vehicles incorporate advanced materials and aerodynamic designs that maintain structural integrity during the extreme heat and stress of atmospheric re-entry while carrying nuclear warheads to their targets. The Mark 21A represents a significant improvement over previous re-entry vehicle designs, featuring enhanced thermal protection systems that prevent warhead damage during the high-speed descent through enemy airspace. Manufacturing techniques developed specifically for these vehicles utilize precision machining and specialized alloys that provide superior performance under combat conditions. These penetration aids deploy multiple decoy warheads that overwhelm enemy missile defense systems, ensuring at least one warhead reaches its target. The decoy system releases numerous false targets that mimic the radar signature and flight characteristics of actual nuclear warheads, forcing enemy interceptor missiles to engage multiple targets simultaneously. Each Minuteman III can deploy up to 8 decoy warheads alongside its single nuclear warhead, creating a target-rich environment that exceeds the capacity of most missile defense systems to engage effectively. The decoys utilize lightweight materials and sophisticated electronics that replicate the electromagnetic signature of nuclear warheads, making discrimination between real and false targets virtually impossible for defensive radars. New solid rocket fuel formulations increase range by 15% while reducing launch preparation time to under 5 minutes. The improved propellant chemistry provides higher specific impulse ratings that translate directly into extended missile range without requiring larger fuel tanks or structural modifications to existing Minuteman III airframes. The fuel improvements result from advanced polymer binders and oxidizers that burn more efficiently than previous formulations, while maintaining stable storage characteristics over extended periods. Launch preparation procedures have been streamlined through automated systems that eliminate manual checklist items and reduce the time required to transition missiles from alert status to launch readiness. Silo hardening improvements completed in 2024 allow these facilities to survive near-miss nuclear strikes and continue operations. The hardening program reinforced concrete silo walls with additional steel and composite materials designed to withstand blast pressures exceeding 2,000 pounds per square inch. Underground electrical systems received electromagnetic pulse shielding and backup power systems capable of maintaining operations for 72 hours without external power sources. Blast doors protecting silo openings were upgraded with improved sealing systems that prevent radioactive contamination from entering launch facilities during post-attack operations. Mobile command centers can now remotely launch missiles, even if all fixed command posts are destroyed in a first strike. These mobile platforms operate from specially modified aircraft and ground vehicles equipped with secure communication systems and launch authorization equipment identical to fixed command centers. The mobile systems can assume control of the entire Minuteman III force within minutes of detecting attacks against primary command facilities. Each mobile command center carries redundant communication equipment and multiple authentication systems that ensure valid launch orders can be transmitted to missile silos regardless of damage to fixed infrastructure. The ground-based strategic deterrent program will replace existing Minuteman III missiles with next-generation Sentinel ICBMs beginning in the late 2020s. The Sentinel program faced significant cost increases during development, triggering a critical breach of the Nunn-McCurdy Act in January 2024, when costs reached $141 billion for acquisition alone. The program experienced delays of several years, but continues development with the Air Force implementing cost reduction measures while maintaining performance requirements. Sentinel missiles will utilize existing hardened silos with modifications to accommodate the new weapon system's larger size and enhanced capabilities. The new Sentinel missiles feature modular warhead configurations, allowing single missiles to carry different warhead types. The Sentinel missile system incorporates a flexible payload bay that accepts various warhead configurations depending on mission requirements and target characteristics. Military planners can select from multiple warhead options, including high-yield strategic warheads for hardened targets, variable-yield warheads for urban areas, and specialized earth-penetrating warheads for deeply buried facilities. This modularity provides unprecedented flexibility in nuclear mission planning, while reducing the total number of different missile types required to cover all target categories. Advanced trajectory planning lets these missiles approach targets from unexpected angles, defeating defense systems designed for traditional ballistic paths. The new guidance systems calculate non-ballistic flight paths that utilize atmospheric maneuvering to change direction multiple times during flight. These trajectory modifications allow missiles to approach targets from directions that defensive radars are not optimized to monitor, creating gaps in enemy surveillance coverage that missiles can exploit. The maneuvering capability extends to the terminal phase of flight, where warheads can adjust their final approach angle to strike targets from optimal directions for maximum damage. Electromagnetic pulse shielding protects launch systems from high-altitude nuclear detonations designed to disable electronics. The EMP protection systems utilize Faraday cage principles and specialized circuit designs that prevent high-energy electromagnetic pulses from damaging critical launch equipment. All electronic systems within missile silos and command centers incorporate hardened components rated to withstand EMP effects far exceeding those produced by high-altitude nuclear bursts. The shielding systems extend to communication networks and power distribution systems, ensuring that missiles remain operational even after enemy EMP attacks designed to disable American nuclear forces. With launch-on-warning protocols now automated, these missiles can be airborne within 180 seconds of detecting incoming threats. The automated systems process data from multiple early warning sensors, including satellite-based infrared detectors, ground-based radars, and submarine-based sonar networks, to identify incoming ballistic missiles.